So the last topic in our unit is actually surface area. And well, what consists of surface area? Well, just like the name says, in any shape. So let's say that I have a prism. So if I look at each of those faces, I can calculate the area for each one of them. So I would have this face, I would have this face, this face. I would also have another face, which I'm not showing here, one down below and one here on the back. So if I open up, let's say that this is a square-based prism. So I would have a square, right? And it's just like a net if you think of it, right? So you're gonna have this, right? Now, if let's say, let me draw this better here. So that's a prism, right? Now, if it's square based, so this length is L and this height here is H, then we would have this to be H and any of those small sides here to be L. So if we work out the area, what would we have? Well, we would have four rectangles which are the same. So the surface area for this object would be two squares. So each square would have area of L squared, and then four rectangles of area for LH. L here is the side of the square and H is the height. So fairly simple. If the shape was different, let's say, what if it's a triangle-based prism? Well, you'll have less rectangles and still two triangles. So the area here would be the area of the base, right? 2 times the area of the base, which is this here L squared is area of the base as well, right? Plus 3 times, and then here that's L, height, and here let's call this L as well. So it would be LH. And then the area of the base, you can just work out the area of the triangles that you've done before, right? So basically, if we have a prism, we're going to open it up, and the number of rectangles that we have is the number of sides in our base. For example, if it's a hexagon, so if our base is a hexagon, we will have 6 rectangles when we open our net, right? And another hexagon here, and then you can just use the equations that you know to calculate the area of the hexagon. You can either use for example 6 times the triangles. You can split those into triangles just like we did before and then calculate the area of each of those equilateral triangles. Alright, I'm assuming here that all those bases, they are regular. Now what would be the difference now instead if I had a cylinder? So what if I have a cylinder? Well, if I open it up, it would be a rectangle with 2 spheres. Sorry, with 2 circles. Now the circle is fine if this radius is r and this height is h, then the area for one of those circles would be pi r squared, right? And this one as well. Now this height is our height h, but what about this length of this rectangle here? What about this length? Well, if we observe, this is a circle, so this distance should be the circumference of the circle. So this should be 2 pi r. So in this case, the surface area, the total surface area for a cylinder would be 2 times the area of the circle plus this length, which is 2 pi r, times the height, which is h. right? So far some very basic shapes and their surface areas. Now what about pyramids? So let's have a pyramid here. So let's say it's a square based pyramid. Okay, so it's a bit approximate here. Those lines which are on the back, they should be dashed. So if I open this up, how would it look like? So basically it would look like a square. In this case it's a square based pyramid, and we have our triangles here, right? Each of those sides, and then we would use our trigonometry, everything that we know, our geometry to calculate those the area of each of those triangles, right? Now there are some shapes which are a bit more difficult for us to find a proof. Some of them would require calculus. So for example, if I've got a sphere and I open up that sphere, and let's say the sphere's radius is r, then the surface area of the sphere would simply be 4 pi r squared, right? If we have a cone, what about a cone? What if we open it up? So if you open this cone up, it would basically unroll, right, between quotes, this area here outside and have another circle. This looks like a party hat. If any of you had one of those when you were young and opened it up, you would find a shape like this one. And well, if you have this length here, it would be exactly this one, right? And again, this length would this arc here, this arc length would be a full perimeter of the circle. So that's the circumference. So this is 2 pi r. This is radius r. This is radius r, right? And there you go. Now for this last problem, let me just show you a bit more. First, let me change this name, just so let's call this length, okay? And let's call the height of our cone h. So then it makes a bit more sense. So if we're calculating the area, the surface area for this cone, we could simply add the surface area of this circle here, which would be pi r squared plus, now how do I find the area for this arc length? Well, pi r l, right? Now this last step here may seem a bit far-fetched, so let me show you how to get to it. Now let's say that we have an arc, right, and angle theta. Now I know, let's say this is our theta, okay, that's what we're analyzing. So L here is our radius, and this arc is 2 pi r. Now if we remember our equations, we would have that the arc is theta multiplied by the radius. So if we apply to this logic here, we would have 2 pi r is theta, which we don't know and we don't want to know, multiplied by this L. Okay, those would be unknowns which are not in this problem here. R here has a different meaning. Now if I rearrange this, I would have theta equals to 2 pi r over L. Now if you also remember the equation for the area, so the area of an arc, it would be the arc itself multiplied by the radius divided by 2. So the arc here is 2 pi r. Oh, sorry, it's the angle. Right, so the angle here is 2 pi r over L times the radius. In this case, our radius is L and 2. So if we cross those out, oh, and I forgot a square here, right? So that would be L squared. So we only cross one of those squares out. That's pi r L, and that's what we found here. Now let's cover a few examples. So find the total surface area of a rectangular based pyramid, rectangular based, so 10 and 8, they're different lengths, dimensions 10 and 8, where the slant heights, so the slant heights are these sides that they go along with the surface. Alright, so it would basically be the height of our triangle. So the slant heights are 12 and 13 respectively. So find the total surface area. So we'll have one rectangle, which is our base, and we'll have then 4 triangles, 2 pairs of equal triangles. So let's go in steps. So first, our rectangle. So our rectangle, one of the lengths is 10, the other is 8. Everything is in meters, so all of my answers will be in squared meters. So this area here will be 80 squared meters. Now let's go for one of the triangles. So if I look at this triangle AB, we're missing E here. So ABE, my height is 12 and my base is 10. So area of a triangle, that would give us, just multiply those, since this is a height and this is a base, we don't have to do any sign of any angle. So it's just 12 times 10 divided by 2. So that's 120 divided by 2, 60 squared meters. And then it's important to notice that I'll have 2 of those. Right? I'll have 2, one here in the front, and this DCE, which will also be exactly the same. Now the other triangle that we have is this BCE. So BCE, my height is 13 meters and my base is 8 meters. So if I calculate my area, same thing again. I know the height, I know the base, I'll just multiply those two. So 13 times 8 divided by 2, that should be 52 squared meters, right? And then again, we've got 2 of those. So the total surface area, so I'll do SA now, surface area. It would be this one, which is the base, just once, plus 2 times this 60 squared meters, because I've got 2 of those, plus 2 times as well this 52, because I've got 2 of those. I've got this BCE and ADE. So this final result would be 304 squared meters. Alright, so our last example here A cone has a radius of 5 centimeters and a total surface area of 300 squared centimeters, rounded to the nearest integer. So find A, the slant height, L, of the cone, and B, the height, H, of the cone. So first of all, we are given the surface area. So we know that the surface area is 300, and I'll put the units in, and let's assume that everything is in centimeters, squared centimeters, and such. So 300. We know that the radius is 5. Now we do know one equation for the total surface area of a cone, and that is 2 pi RH plus 2 pi r squared. Okay? That's one way of looking at it. If we are using this equation, this would be our cone, right? Obviously our cone is three-dimensional, but we're just looking at one flat cut of this cone. So this is, let's say, point A, B, C. I am cutting a triangle just at the center of our cone, so it's going through the center. So this is our radius here, 5, right, this distance. This would be our height, H, and this is the slant height, L. Okay? Now, since we're just looking for the slant height in this first case, we could do pi times 5 times L plus pi times 5 squared. Oh yeah, this is, oh my god, this is wrong. This is pi RL plus pi r squared. That's exactly in the previous slides, right? So now there you go. So if we just put the numbers in, we would find pi RL, r is 5, that's our radius, r squared here is 5 squared. So if we just find those, since you're allowed to use a calculator, right? If you're not, then you can work out the numbers, 300 minus this. But since you can just put that in your calculator, you would find that L is approximately 14.09, something that keeps going, which up to 3 significant figures would be 14.1. Alright? So letter A is done. Now what about letter E? We're looking for the height now. So for the height, we can look at this triangle that I've drawn before. So if this is our radius r, which is 5, this is our slant height, which we have found to be approximately 14.1, and we want to find the height. So Pythagoras, we can just do, this is our hypotenuse, so 14.1 squared would be h squared plus 5 squared. Since we're looking for the height, we can do height squared is equal to 14.1 squared minus 5 squared. So h would be the root of that, which is 13.2 up to 3 significant figures. There you go.